Hello science fans! Welcome back to another exciting day in our data science adventure. Today is January 27th, 2026, and we're on day 17 of our data science journey. We've already learned so much, but today we're tackling a challenge that every data scientist faces sooner or later. Information overload. Imagine you're baking a cake, but your recipe lists every item in the supermarket. Flour, sugar, eggs, but also fish, pickles, and even laundry detergent. It sounds ridiculous, right? But that's exactly what happens when we have too much data and don't know what to do with it. All that extra information isn't helpful. It just makes things confusing and wastes your time. Instead of making a delicious cake, you end up lost in a mess of ingredients, unsure of what to use and what to ignore. In data science, these ingredients are called features. Features are the different pieces of information or variables we use to build our models, and choosing the right ones is crucial. Too many irrelevant features make our models worse, not better. They can slow down our computers, make our results less accurate, and even hide the patterns we're trying to find. Our job as data scientists is to clean up the data and select only the most useful features, a process called feature selection. This step is like tidying up your kitchen before you start cooking, making sure you only have what you need. By focusing on the right features, we make our models faster, simpler, and smarter. This means we can solve problems more efficiently and get better results with less effort. So, let's put on our data detective hats and learn how to separate the useful clues from the noise. Get ready to discover the secrets of feature selection and make your data science project shine. Let's talk about the curse of dimensionality, a real challenge in data science. It's a problem that sneaks up on you as your datasets grow larger and more complex. At first, adding more features seems like it should help your model learn better. But in reality, it often makes things much harder. The more features or dimensions you add, the more your data spreads out in space. This spreading makes it increasingly difficult to find meaningful patterns or clusters. Instead of helping, extra features can actually drown out the important signals in a sea of noise. As dimensions increase, the data becomes sparse, so sparse that even the closest points seem far apart. This sparsity means that traditional algorithms struggle to make sense of the data, and the relationships between points become less obvious. Imagine searching for your keys in a small room versus an entire city. The more space, the harder the search. In high dimensions, it's like looking for a single grain of sand on a vast beach. In high-dimensional data, every point starts to look like an outlier. Models can't easily tell what's normal and what's not, so they struggle to find meaningful relationships or make accurate predictions. Each extra, irrelevant feature makes the problem exponentially harder. Not only does it slow down your model, but it can also reduce accuracy by introducing confusion and noise. Your computer works over time, but the results get worse. That's why feature selection is our superpower. By carefully choosing only the most relevant features, we shrink the haystack, making it much easier to find the needle, the patterns that matter most. The right features help your model focus, learn faster, and perform better. You get clearer insights, more accurate predictions, and a much smoother workflow. Don't let your data get lost in a vast, empty space. Without feature selection, you risk missing the story your data is trying to tell. Feature selection keeps your analysis sharp and efficient, helping you find the answers you need, quickly and confidently. Another danger of too many features is overfitting. Overfitting happens when a model memorizes the training data, including all the noise and quirks, so it fails on new data. Imagine a student who memorizes practice questions but can't answer anything new on the real test. Extra features let the model find weird, useless patterns that don't generalize. By reducing features, we force the model to focus on what really matters, the true signals, not the noise. Simpler models with fewer features often perform better in the real world. Feature selection helps your model generalize, making it reliable and robust. Remember, a simpler model is often a smarter model. So, how do we actually select features? In the world of data science, choosing the right features is a crucial step that can make or break your model's performance. With so many variables in a dataset, it's important to know which ones truly matter and which ones are just adding noise. Data scientists use three main approaches: filter, wrapper, and embedded methods. Each of these methods offers a unique way to sift through data and identify the most relevant features for your model. Filter methods are quick and straightforward. They use statistical techniques to score and rank features, completely independent of any machine learning model. This means you can get a sense of which features are most promising before you even start training. Wrapper methods, on the other hand, are more powerful, but also more time-consuming. They actually train models on different combinations of features, testing each set to find the one that delivers the best results. This can be computationally expensive, but it often leads to better performance. Embedded methods are perhaps the cleverest of all. They select features as part of the model training process itself. The model learns which features are important while it's being built, making this approach both efficient and highly integrated. Some algorithms, like lasso regression or decision trees, have built-in mechanisms to automatically identify and prioritize important features, saving you time and effort. Each method has its strengths. Filters are fast and simple, wrappers are thorough and can yield high accuracy, and embedded methods are efficient and often very accurate. The choice depends on your data, your goals, and your computational resources. Knowing when and how to use each method is key to building great models. It's a skill that separates good data scientists from great ones. Today, we'll focus on filter methods, your first line of defense when tackling a new dataset. They're especially useful for quickly narrowing down your options and getting a head start on your analysis. Mastering these techniques will make your data science projects smoother and more effective right from the start. Let's dive in and see how filter methods work in practice. Filter methods are the quickest way to clean up your dataset. They analyze each feature's statistical properties. No model training required. First, ask, is this feature related to what I want to predict? If not, drop it. Next, is this feature just repeating information from another? Highly correlated features are often redundant. Finally, does this feature even vary? If every value is the same, it's useless for prediction. Filter methods are fast, simple, and work on any dataset. Let's look at the most common filter techniques with some examples. One powerful filter method is checking correlation with the target variable. Correlation measures how two variables move together, from one, opposite, to +1, same direction. For example, if you're predicting exam scores, hours studied might have a strong positive correlation, while shoe size has none. Set a threshold. Features with correlation below, say 0.2 in absolute value, are likely irrelevant. Keep features that pass this test. Remove those that don't. This quick check ensures your model focuses on variables that actually matter. It's a simple way to rank features by predictive power. Why include features with no relationship to your target? Correlation filtering is a fundamental first step in cleaning your data. It makes your model more focused and interpretable. Next, check how your features relate to each other. This is where multicollinearity comes in. Multicollinearity means two or more features are highly correlated, like height in summits and height in inches. Redundant features confuse models and make results unstable. To spot them, create a correlation matrix and look for pairs with high correlation, e.g., above 0.85. If two features are nearly identical, keep the one more strongly related to your target. For example, if house size (SQFT) and number of rooms are highly correlated, keep the one with a stronger link to price. Removing redundant features makes your model simpler and more reliable. Multicollinearity can distort your results. Don't let it sneak into your dataset. Use this filter to keep only the most informative features. Your model will thank you. The variance threshold is the simplest filter method. Remove features with little or no variation. If a feature has the same value for every row, it can't help predict anything. For example, if all students are in grade 10, the grade level column is useless. Calculate variance for each feature and drop those below a small threshold, often 0. This also works for features with almost no variation, like a survey question where nearly everyone answers the same. Removing low variance features declutters your data and sharpens your model. It's a fast, safe way to get rid of dead weight. Focus on features that actually help your model make decisions. We've explored why feature selection is essential. Too much information confuses models and hides real patterns. Filter methods are your first, fastest tools. Check correlation with the target, spot multicollinearity, and remove low variance features. These steps make your models faster, simpler, and more accurate. Remember, filter methods look at features one by one. They're a great start, but not the whole story. More advanced methods, like wrappers and embedded techniques, can find deeper relationships. For now, you have a solid foundation for cleaning any dataset. Keep experimenting. Feature selection is the key to smarter models. A clean dataset leads to a happy model.